In this video, we will be showing the model converter GUI and how to download a pre-trained TensorFlow model, converting it to a DeepView RT model, and running a simple image classification example on the Raspberry Pi. So to start, we're on the DeepView Zendesk support page, and under the Getting Started section, if you expand it to see all articles, we provide a list of public repositories for obtaining models. This details a few different places to download models between TensorFlow Hub, some object detection model zoos, and for this example, we'll be grabbing an image classification model from TensorFlow's hosted model page. There are many models available here, as well as their expected performance on a Pixel 3 type phone and their various accuracy. Go ahead and download the largest of the MobileNet V2 models. Now this bundle includes both the TensorFlow and TensorFlow Lite models. Either can be used, but we'll go ahead and use the TensorFlow Lite model for the converter. So here, you see the various files that are included. We'll go ahead and extract the TF-Lite file. We'll extract to the download directory. Now we can open up the RTM tool, which is the DeepView model converter. And from here, we can drag and drop the TensorFlow Lite file, which we extracted, and it will create a RTM file. So we can go ahead and click Convert here and see that the process completes. Now, one piece with RTM files is the labels list can be embedded directly into the model, so that when running with an application that loads various models, you don't need to also provide a label list. The application can query it directly from the model. So the labels lists are not included on the website here, but under our FAQ section, we do provide a link to the ImageNet models used by the various mobile nets or any of the other models trained using the TensorFlow Slim framework. So if we go up to Raspberry Pi on the site here, and under FAQ, there are the ImageNet labels. You can go ahead and download these. If you open the file, see it's just new line separated labels for all the 1001 labels provided by ImageNet. So now in the converter, we can paste or drag and drop the labels down into the labels file here. And now when we do the conversion, the labels will be included. Now, generally, all TensorFlow Lite and TensorFlow models can be converted to an RTM successfully, but the conversion involves both an optimization pass as well as removing layers from the network that are not required or potentially unknown. So there is the potential that this leads to errors. The validator over here can help find these. So when validate is selected, what we do is we generate a random input and we feed it through the TensorFlow or TensorFlow Lite model and collect the output. And that's being run using the underlying TensorFlow or TensorFlow Lite engine. And then from there, we take the RTM and that same generated input and run it on the DeepView engine and then verify that the two outputs match. So in this case, it shows that all outputs matched. So we know that the model validates numerically against the original TensorFlow Lite model. So that's it for the model tool. We can now take a quick look at what this model can do. Now this is a simple, this is an ImageNet model, so it has various somewhat arbitrary labels, but one of them is Panda, so we've included an image of that. So here we can copy and paste, drag and drop the RTM. Now you'll notice it gives a warning about unknown normalization. We'll review this in the advanced model conversion video, but for now, suffice to say that this model uses signed normalization, which is the default when no normalization is selected. So we have an image of a panda here. Drag and drop this into this image classifier, and we can see that it correctly classified as a giant panda. And we see here the inference time, codec time refers to the time it takes to decode the PNG or in this case JPEG image. And we can see the size of the model, which is 13 megabytes. We can drag and drop this a few times and see the timing varies slightly in the GUI run to run, but it's approximately 70 to 90 milliseconds for the largest mobile net on a Raspberry Pi device. So that concludes this video. In the next video, we'll be looking at some of the more advanced options of the model converter, as well as how to embed the correct normalization method into the model so that it's known automatically by any tool that's aware of normalization probing in RTM files. Thank you.